Welcome to the GOTO podcast. In this episode, Saša Jurić, author of Elixir in Action, and Erik Schön, managing director of Erlang Solutions Nordics, explore the key benefits and best practices of functional programming language Elixir. Created for developers by developers, GOTO gathers the best minds in the software community. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in Chicago, Amsterdam, and Copenhagen, and by subscribing to the GOTO Conferences YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech. We kicked off the conversation by asking Saša, what is Elixir?
So Elixir is a programming language. In theory, you could say that it's a general purpose programming language, but in my personal view, it has like its particular sweet spot of what kind of programs can you write with Elixir, and such programs are what I call software systems. And by that, I mean any kind of program that runs on the backend side of things, any kind of a server-side program, such as a web server, but also, for example, say a database or a message queue. And what is particular for software systems compared to other types of programs is that once you put them into production, you start them for the very first time in production, they have to be running for a long period of time, constantly, continuously for a long amount of time, like a couple of years or maybe even a couple of decades. And during this period, you don't really want them to go down, because that essentially means that the system is not providing any service at all. Another particular property of a software system is that at any point in time, it's doing a bunch of different things, a bunch of different activities are happening within the system. Like, say, all of us are making requests to a web server, and each request by a different person is its own separate activity. But beyond just handling requests, the system has to do other things, like, say, run background jobs or periodical jobs. It might need to manage some kind of an in-memory state, such as cache, for example. It might need to do some load control, such as applying back pressure or rate limiting. So a lot of stuff is happening just beyond plain request responding. And what's interesting is that these activities are mostly mutually either very loosely dependent or in many cases even completely independent. Like, say, your request and my request are typically, completely unrelated. And what this means is that in a software system, the semantics of success are not binary. You have like degrees of success, which is not true for every type of program. Like if you take, say, a compiler or typically any kind of a command line tool, these programs get some input, they do some processing, they produce the output, and they can either succeed or fail. There is nothing in between. But for software systems, you have these degrees of success. So, like, of course, ideally, we want the system to always work for everyone, but clearly this is not possible because, ultimately we're humans and we're going to produce some bugs and some things will go wrong. And even if we are able to write perfect software, this software runs on some hardware, which will occasionally fail. Typically, in many systems, we depend on external stuff not developed by us, like, say, external database or third-party services, like, say, payment gateway, for example. So these things might fall and it's completely out of, or might fail, right? And that's completely out of our control. So things will go wrong. But because there is a non-binary idea of success, we can capitalize on this and implement the system in a way that it provides as much of the service as possible at any point in time, even when something goes wrong, which is better than, providing nothing. And so this is a very particular challenge for any kind of a software system. And this is what I like to call, what for me is high availability. It's not about, chasing some mythical amount of nines of uptime. It's about providing as much of the service as possible for our users, and also, of course, the system should be able to automatically detect when something goes wrong and recover automatically from that failure as soon as possible, given the circumstances. So those are the challenges of software system. And again, they are really applied to any kind of a software system, regardless of the particular business domain or even scale. Even in smaller systems and simple systems, you still want your system to be mostly up and running and providing as much of the service. Now, Elixir as a language gives us tools to address those challenges, gives us, like basic building blocks, very simple in their nature, but very powerful and flexible to approach the challenge of high availability in a systematical fashion. Now, I want to say that Elixir is not the only such language available for this job. There are a couple of other languages, like, for example, Erlang, or Lisp for Erlang, or Gleam as an example of a newer and a strongly typed language. And what ties all these languages together is the fact that they share the same runtime, which is called Beam. And this is the name of the Erlang virtual machine originally designed or written for the Erlang programming language. And now, with time, we have a bunch of other newer languages built on top of Beam. And Beam is really the secret sauce here, which allows this story to happen, which allows us to build highly available systems.
So, Saša, speaking of the Beam here, I mean, that's the Elixir virtual machine. How would you say that compares to other virtual machines that people may be more familiar with, like the Java virtual machine, the JVM, for instance?
Mm-hmm. Yeah, so what I personally find about Beam is that it really has a strong focus on what it wants to do, and this is to power the software systems, highly available, long-running programs which should ideally never fail, never go down completely. And Beam has been built from the ground up, from the day one, even day -1, if you will, before it didn't even exist. There was a lot of thought put into it, how to build such a runtime. And so Build provides many things at the runtime layer, which other runtimes typically do not. Let me briefly explain how it works on Beam, so it's going to be clearer. So essentially, the way it works is like when you build your program in a Beam language, such as Elixir or Erlang or other languages, you will start your program and a single operating system process is started. And this is the instance of Beam where our program is running. If I run 5 Beam programs, I'm going to have 5 of those instances, 5 OS processes. Now, within a single Beam instance, we can start many small, lightweight, independent programs, which we call processes. So just to clarify, process is not an OS process. OS process is one Beam instance, and then within a single Beam instance, you can have a bunch of these small processes. And when I say a bunch, I really mean like a large number, like hundreds of thousands, millions, up to, I think, around 100 million processes per single Beam instance. Now, these processes, these programs are completely isolated from each other. So they share no memory at all. They have their own separate memory space, and they can only communicate through sending themselves messages, which is also known as message passing concurrency. And they are completely isolated from each other. So like if a single process crashes, if that single small program crashes, all the other processes in the system are still up and running, so they will not fail. And this crash can be detected. And these are like the basic foundational stuff that we get at the Beam level. Now, what this means is basically, I like to sometimes say that like we have support for microservices, at least some parts of microservices directly at the runtime layer and therefore directly at the language level. We can do stuff for which in other languages you have to fall back to the OS level and run a bunch of different OS processes and different components and orchestrate them through some service manager and whatnot. You can do a lot of that stuff directly in a Beam language such as Elixir. And so the idea of building a fault-tolerant and highly available system is, like in its basic form, it's like very simple to me. Like let's say a system has to do this huge amount of job. Everything the system has to do, like it's like some huge big square. If you take this big square and somehow strategically split it into a small number of independent or loosely dependent programs, then suddenly no one is too big to fail. Right. And so if you experience some sort of an error in a particular part of the system, like maybe there is some division by 0, square root of -1, something unexpected happens, still most of the system is up and running and we are still providing as much of the service as possible. And at the same time, because failure and in general, the process termination is not a silent event, so any other process can be notified about it, you can implement self-healing strategies. So like one process crashes, the other one gets notified about it and starts a new process in its place, or maybe redirects some jobs to another process that is still available. So it's like a pretty simple but very powerful idea. Compared to other virtual machines. Well, I didn't do it like a thorough comparison, but in general, as far as I know, no other runtime layer has such support for high available systems or such focus. In particular, for example, in JVM, as far as I know, there is no lightweight concurrency at the runtime level. People do this on top of JVM. So the most notable example is Akka, which takes a lot of ideas from Erlang, and brings also a lot of other interesting ideas to the table. But this is implemented at the library level. So like you implement Akka in a language, I don't know in which language is it written, probably Java. But what this means is that you kind of fall short. You basically can do only what your runtime can do. So, for example, in Beam, these processes are scheduled preemptively, so to speak. So like when a single process runs in an infinite CPU bound loop, it's moved out and someone else gets the slot. So you can terminate a process even if it gets stuck completely, even if it refuses to stop. As far as I know, these things are not possible in Akka or anything else because you essentially don't have the support from the runtime. The runtime doesn't know about these lightweight concurrency entities. So in my view, Beam is really very focused and very well built. It's a really stable runtime. Has been around for more than 20 years or so. Erlang itself is old. I think about 30 years or maybe even more if you take the design phase into account. So very stable, proven in practice in large systems and diverse systems such as WhatsApp, for example, and of course in Ericsson telecom systems. So it's, as far as I know, the best option we have available today, or the most suitable option that we have available today as a foundation for building software systems, or again, highly available fault tolerance and scalable programs.
So yeah, I fully agree with you, Saša. And this is really captured in the saying, write once, run forever, right? That's sort of the essence of what you just described, right? In the community now, there is a lot of talk about Golang and Darklang, and that are in some aspects similar. What are your thoughts on sort of the differences and similarities between these languages and the languages on the Beam, Elixir being one of them, of course?
Mm-hmm. Yeah, so let's start with Go. So in my view, Go is a really great language for building tools, the complete opposite of software systems, because a tool, especially like if you want to distribute them massively to a large audience, which runs, a bunch of different operating systems and whatnot. So Go really has a great deployment story, which I really like. You build this standalone binary and give it away and it works, So this is super great. I think as far as I know, it's probably the state of the art in that particular area. It's very simple language to pick up, so those are like pretty good things. But I personally, and I know that people are building systems with Go, but personally, I don't feel that Go is as good of a fit for that job as Beam languages. So Go does have lightweight concurrency, but that's pretty much all it has. So it's not just about having lightweight concurrency. It has to be designed in a particular way if you want to build software systems with it. In Go, for example, all these Go routines are sharing memory, which can lead to all sorts of strange problems and bugs. If a Go routine crashes, then the entire program crashes. So, think about like if you have a single Go program, which runs, I don't know, maybe 1 million of Go routines. You are, handling WebSocket connections to some real-time game server or something like that. And there is a single bug, you have somewhere square root of -1, single Go routine crashes, all of these connections go down. And this is like super disruptive for all the users. This is the kind of thing that will not happen in Beam when you design it properly. You will just have one process crashing. Then Go also basically still has cooperative scheduling. They did a lot of improvements there, but as far as I'm aware, they're still not completely preemptive. So you can still end up with a Go routine which just, runs in some longer CPU bound loop and just takes up a single scheduler, and a couple of such routines basically block your entire system. And also, you cannot really terminate Go routines. This is a very interesting thing that you have on Beam. So in Beam, because process is a runtime entity, you can terminate it by the runtime. You can ask the runtime, please stop this thing now. And no matter what it does, it's going to be stopped now because, this is the runtime level service. And so this is the first class cancellation at the runtime layer, that kind of things pretty much are not possible to implement reliably or completely reliably on in Go or in, say, on top of JVM, again, because the runtime doesn't have the support for that. Just maybe as a passing mention, I explained this in more details through a demo-driven presentation about a year ago when I was talking at GoTo Chicago, giving a talk called The Soul of Erlang and Elixir. So, I'm giving a very high level overview here, but if you want to see this in action, you may want to check out that talk. So yeah, in general, I think that Go, for me, personally, I would definitely use it and recommend it to build tools, to build one-off programs. Works pretty great for that. Probably the best in class for many such scenarios. But for software system, again, I understand that people are building large and interesting things with that. But personally, for me, that would not be the choice. I feel that Beam languages are a better option. Now, when it comes to Dark, this is a very interesting story. So I really like Dark. What I've seen, so I didn't really get to try it, but I just saw a couple of presentations. I think that Dark really has a very important story, and this is the story that Dark starts with the premise that backend development is very complex because you have to use a huge amount of different tooling and somehow glue it all together. This is like the modern state of art. You start with Kubernetes and then run a bunch of different components, and you split your system into a bunch of different microservices and whatnot. And the amount of technical complexity we introduce here is crazy. This is like definitely server-side, backend-side programming is way too complex these days. And so Dark aims to solve this by being like a single tool. You learn this one tool and you can do everything with Dark. It reduces a huge amount of this technical complexity. And I really like this story. Now, what's interesting is that you can sort of get a similar story on top of Beam languages, precisely because Beam already at the runtime level gives you a lot of the things that you get otherwise from the operating system. Indeed, we sometimes say that Erlang or Elixir is like an operating system for our code. When you have operating system services in your code, then you don't have to fall back to the operating system level, and you can do a lot of stuff from the language. And I've had a bunch of these examples in practice where I built a system using exclusively Erlang or using exclusively Beam with nothing else running on the side supporting it. Like no Nginx, for example, no external in-memory KV, because we have like an in-memory key value storage called Erlang Term Storage or ETS. Things like that, when with other languages, I would have to fall back and run a couple of different processes and a couple of different third-party components and glue them. And again, this is a huge amount of technical complexity. With Erlang and Elixir, you can frequently, get away just fine with a single project and a single OS process running per each machine in the cluster. And I believe that basically with Beam, you can get similar sort of properties that Dark aims to give you. However, Beam and the entire ecosystem is kind of a ground up story. It's more like a toolkit, less than a framework. So with Beam and standard libraries of Erlang and Elixir, you get like a relatively low level abstractions, and then libraries give you some medium level abstractions. And what we are kind of lacking, Dark sort of starts from the opposite direction, are like super high level abstractions. So ideally, this is perfectly possible. We have good foundations in place. And again, in my view, you can typically implement something like that on top of Beam and not many other platforms. But we are lacking these high level abstractions, and I would like to see the ecosystem evolving to the point where, like when I say I want to build a small to medium distributed web-facing system, and in 15 minutes, I bring in a couple of libraries, a single project, and bam, it just works. This is perfectly possible, and I would really like to see our ecosystem getting there.
Yeah, and I think that's a very good comment. I think the ecosystem around Elixir and the Beam is fantastic, and I'm sure there are brains as we speak thinking and working on exactly those things. So, slightly related topic. I was listening to another episode on the GOTO Book Club on Elm in action. And, Elm being a total different beast, of course. But what I found interesting there is the approach taken to static typing. It's very, very rigid. What are your thoughts on static typing for the Beam and Beam languages?
Mm-hmm. So, in my view, the lack of static typing is the biggest deficiency on Beam languages. And I mean, I know that there are like camps, dynamic versus static. I personally, done both for like many years. And for the past 15 years, I've been mostly using dynamic languages, and I'm now pretty much certain to say that I believe that static is definitely a better option. I still love Erlang and Elixir, and these are like my first languages, regardless of the lack of static typing, because they offer something that I cannot find anywhere else. But I would love to see static typing story on Beam languages. Unfortunately, mostly it hasn't been available. So what we have for Erlang and Elixir is what is called success typing through the tool called Dialyzer, which I like to say is far from perfect, but it's the best we got. However, there are very interesting initiatives. There is one language called Alpaca and another language called Gleam, which look very, very promising. And they basically aim to bring static typing into the Beam world, like, proper sound static typing. And this is something I'm super excited about. I still didn't have the chance to try them out, but I would definitely love to see how this story unfolds. One challenge, with Beam languages is because you really have two dimensions in those languages. So like there is a functional dimension. So Erlang is a functional language and Elixir is a functional language. Typically all Beam languages are functional because somehow the runtime itself is tuned to that. And but then there is a whole other dimension, which is concurrent dimension. That's what I talked about, the ability to run and manage a large number of programs within a single OS process. And this is usually lacking from other languages. And like these two dimensions are serve completely different purposes. And the challenge is, I'm curious to see how this will be solved in like Gleam, for example, is how to get type safe message passing, for example. So this is going to be very interesting to see how it unfolds. But in any case, I'm certain that strong typing can be added to Beam languages, and I'm very, very excited about Gleam, and I'm looking forward to see how it unfolds.
Yeah, I fully agree with you. I think that's a very interesting story, and there's even rumors that WhatsApp, they're being a big user of the Beam language called Erlang. They are very much into strong typing, and they even invented different new versions of languages, including strong typing. So let's see how that plays out. I'm really excited. So moving a bit into Elixir, what would you say are the key benefits from a business perspective? Let's say a business user considering Elixir. What would be the key benefits from that angle?
Mm-hmm. So, right. As I said, Elixir, like any other Beam language, for me, it should be strongly considered when you want to build a server-side system. And I don't want to repeat all that again, but definitely, give it a try, at least give it an evaluation. But of course, it begs the question, why would we choose, say, Elixir over Erlang, which is the first Beam language, and clearly, like the whole runtime has been designed for Erlang. And there are, of course, other languages as well. So in my personal view, and just to be clear, I'm not the member of the core team, or I'm not the creator of the language or anything. So I'm just a user. I always like to say I'm a happy user of Erlang and Elixir. And my personal impression is that what Elixir brings to the table compared to Erlang is better approachability and maybe a better developer productivity story. So I have been using Erlang in production for a couple of years before, Elixir even existed. And then through the middle of the past decade, I was using both languages side by side. And finally, a couple of years ago, I moved completely to Elixir. And I like to think that I had like a good, practice with both languages. And so I could have seen like pros and cons. And the thing is, in my view, Erlang is a very simple language. People get confused. People think that Elixir is simpler, but that's not true. Erlang is a simpler language. It just looks strange to most people because it has this prologue-like syntax, right? But like very, very simple language. And that's really cool. Very simple syntax and very regular syntax. No ambiguities at all. But that's the problem with simplicity as well, because the simpler the language, also the less expressive it is. So what I found in Erlang is that I had to write a lot of repeating boilerplate and what you could call noise. I know some people would say that it's like more explicit than, but my personal sentiment is that it's more noisy. And so Elixir, I would say, which looks maybe more approachable for the syntax, which is the least interesting part, but it has like this Ruby-like syntax, which many people are used to. But what really, in my view, is Elixir versus Erlang is it's a more complex, more complicated language. So there are more things to learn. But because of that, you as a programmer can also be more expressive. So you can actually reduce and put aside some boilerplate. And so I found that it strikes a better balance for me personally. But, I wouldn't dare to say that either one of these two languages is better. It's more about, your own personal preferences of whether you like to, write a bit more and then have that boilerplate, but also, the simpler language, or you prefer to have like more complex features in the language. But then, you also can reduce some noise. So it's a matter of personal preferences to me. Now, another thing that Elixir brought to the table back when it originally appeared. So I believe that Jose Valim started writing it in 2011, if I remember correctly. I personally saw it in like early 2013. And at that time, my impression was that Elixir had a much better tooling support. So basically Erlang didn't have official tool at the time. So you had to use some third-party tool, which now has been integrated and which is now actually much better. So the story in Erlang has improved as well. But with Elixir, you just get this thing and you start this Mix new project and you do everything with Mix, and it was like very easy to build an OTP release even back at that time when that thing doing it with Erlang was a bit more complex and again required some different tools. Even the community of Erlang didn't have this consensus about which tool you should use. So there were 5 or more different options to do that. So this is where I find, historically Elixir working better. I believe that, I don't really follow Erlang so much anymore, but my impression is that Erlang has improved as well in those areas. And I kind of like to think that, having these multiple choices, that these communities essentially move each other forward together. So we are all like whole Beam ecosystem. And I mean, it's always worth saying that you can use like in Elixir, you can use Erlang libraries, and we wouldn't even exist if we didn't use those libraries, starting from the standard library and the OTP framework, but then also third-party libraries such as the popular Cowboy web server and things like that. And also then again, owing to the work on Elixir, there have been some pull requests done back to the Erlang/OTP. So essentially these two languages, kind of work together, and not just these two languages, but all of Beam languages as they should. So ultimately to me, the question of, say, Erlang versus Elixir is all more about like, do you prefer a simpler language with a bit more typing, or do you want a more expressive language but also more complex language? And again, I think that my impression is that Elixir has like a slightly better story in tooling, in documentation, maybe support for tests and so on.
Yeah, I think you're absolutely right there, and that was a bit of a weakness in the community. And I think that the whole Elixir team with Jose and the others have moved the community forwards as a whole, and now the whole Beam community can benefit from it. So I think that's just awesome work done there. Speaking a bit about your book, I think it's really cool, and I love your T-shirt. So, what kind of person did you have in mind when writing it?
Mm-hmm. Yeah, that's a very good question. Thank you for giving me the chance to clarify that. So Elixir in Action is, I personally advertise it as it's an introductionary book to Elixir, but not for non-programmers. So it's not introduction to programming. I actually expect a programmer who has some experience in other languages not related to Beam at all, such as Ruby, C#, Java, JavaScript, whatever, Python, and so on. Preferably on the server side of things, for at least I would say a year or two. So the reader should be familiar with what it feels like to write a web server, a web-facing system, the way I like to call it. Other than that, of course, they don't have to know anything about Beam or Erlang or Elixir at all. Yeah.
Nowadays, there are quite a few books on Elixir out there on the market. So what would you say is unique with Elixir in Action?
Mm-hmm. I actually, up until a few years ago, I read all of books written on Elixir. These days, that there are like already so many that I find it hard to catch up. My personal impression is, obviously, I'm partial to my book, but that my personal impression is that all of these books are great books, and that mostly they complement each other. So in particular, for Elixir in Action, I wrote it with the focus, again, remember I said there are like 2 dimensions of Elixir, so functional and concurrent. My focus was on the concurrent aspect of Elixir. because this is where I find that any Beam language really shines the most. This is what they bring significant to the table compared to anything else available out there. I'm not saying that functional is somehow boring or anything, but this is the stuff that I kind of treat it more as a nuisance. So that's one thing about Elixir in Action. It starts very uneventfully, very like the first part of the book. Those are the first 4 chapters. They basically deal with functional programming and the type system, and it's more like you have this and you have that and you have that. So you kind of have to survive through this first third. But then the second and the third, so the second part and the third part, they are focused on concurrency, how to think concurrently in Beam, and how to use it properly, and how to use the higher level abstraction from the Beam standpoint, or from those languages like OTP, how to use those things properly. And what I really like about those chapters is that they are sort of modeled through my own experience. Like when I was working with Erlang I started using Erlang in 2010. And back then, there wasn't even the famous book, Learn You Some Erlang. And there were a couple of books I learned from Joe's book, for example. But it wasn't completely clear to me how should I do things, So I made many mistakes. And in a sense, this is replicated in a book. So it doesn't, just guide you in a straight line from point A to point B. But it does more of like a zigzag, I do some things wrong deliberately. So like you start in one chapter and you're gonna start with something, learn some new techniques and build some implementation, and you're gonna feel good about yourself. And then in the beginning of the next chapter, I'm gonna explain why this implementation is wrong, and then we're gonna learn something new, and then we're gonna improve it. And then in the next chapter, you're gonna learn that this is wrong too. But I never let you fall very far, go astray very far. But I believe that in this sense, my goal was to not explain not only how you should do something, but also why you should do something, because this is what I found at the time, like in Beam literature, people will tell you like you should do it like this, and no explanation at all why. And so I made some mistakes which I've seen on forums and other exchange sites that people also tend to make when they don't know this. And this is where I personally find the book, like for me at least, most helpful. And in essence, I wrote this book the way I would want to have it, if I didn't write it in. So something that I was found missing myself.
Now, I really love that approach. It's fantastic way of teaching, because that's the way you learn in reality, right? It's never this straight path. It's always, one step forward, a half step back, and 2 steps forward, and so on and so forth. So having that approach when writing a book is really awesome. Thinking about being a writer myself, I'm curious to what kind of feedback you got on the book, and what kind of feedback was most surprising to you, because you said that you wrote it like you would have liked it, right? So what kind of feedback and surprising feedback did you receive so far?
Yeah, well, the book, so this is now the second edition. If I remember correctly, the first edition was released in 2015. So it's been like now 5 years or so. Yeah, I got to say that I was surprised. First and foremost, I was surprised that I got any feedback. It was the first and the only book I ever wrote, and I wasn't really famous or anything before that. So there were more famous authors writing on Elixir, and I really, didn't expect that anyone would even read the book except for myself and my family. But it was actually turned out like a pretty nice surprise that people actually read it, and I got very good feedback, and it feels like the book has grown sort of organically, So I see people recommending it, and sometimes I get unsolicited feedback. It's just someone, contacts me on whatever channel and say, hey, I read your book and it's a really good book. Thank you for writing it. And this for me is like the best reward that you can get from a book. When you're not fishing for a review or anything, someone approaches you and just say, I read your book and I really enjoyed it. It really helped me.
Thanks for listening to this episode of the GoTo podcast. Head over to gotopia.tech for lots more content from the brightest minds in software development.